Yes, so let's now move to introduce our first speaker on the webinar today. And I want to highlight that he is a senior scientist at NOAA, Office of Ocean and Atmospheric Research. And the reason why I want to highlight it, Roger, is that NOAA CC Run, the RISA program in our that I was one of the founding leaders of, is hosting the webinar series on their website and on their YouTube station. So we thank NOAA very much. But telling you more about you, you are a senior scientist in the NOAA's Physical Sciences Laboratory at Boulder, Colorado. Roger's research focuses on climate, adaptation, and science policy. I knew we'd get some policy in here today. He has been involved in the IPCC as coordinating lead author for the 5th assessment and the US 4th national assessment, and also has very strong ties to the UN Office for Disaster Risk Reduction and the global, and has been a CLA on the that assessment as well, linking the timescales of climate change and response. He directed the RISA program. That's why I wanted to say thank you, Roger. And also the US National Integrated Drought Information System, and co-chairs the WMO Climate Services Information System Implementation Team. And on the academic side, adjunct professor at University of Colorado and the University of West Indies. So I'm going to stop sharing. Over to you, Roger. Thanks so much. It's wonderful to have you. And thank you so much for your fantastic chapter and lecture in the book.
Great. Thanks very much, Cynthia and Manishka. And I fully appreciate the invitation and the opportunity to contribute to Martin's legacy, among other things. And I'm thankful you mentioned the RISAs, because in that name is IS, the integrated sciences, completely developed and derived to help us look at interdisciplinary problems in an integrated way, but then also to act on them. And so I really appreciate your mentioning that. So when we named that program, many people didn't know that it's actually an abbreviation of Sonrisa, which means to smile in Spanish. So as we move along, let me share yes. So that was Claudia Nuremberg and myself did. So here we are. And I take it that's coming across, and then I can start, right? Okay, good. So on this chapter, which is in the book, we're going to really talk about what does it mean to operate, not going from risk to resilience, but on the continuum from risk to resilience. As Cynthia mentioned, there's a strong link between the global assessment reports of the UN Office of Disaster Risk Reduction, the IPCC. I also co-chair the reporting for SDG 6 for the US. I'm originally from the Caribbean, and you'll see that in the way I respond to some of the questions and some of the experiences therein. So as we think about this continuum and how we operate on it, I wanted to highlight exactly what Cynthia was saying. This is a really unique book, and not only because of the authors on it, but the way it was created and the vision behind it, the pedagogical value of it, much beyond static assessments of any kind. This is meant to be a learning document and a living one with lessons and experience coming back from the people in this audience. So let's think through what this means to think about extremes in the context of how we see projections and changes over time, and then locally to globally, what does that matter? How does that matter in terms of how we respond? And the link, especially between what we'll call systemic risks and transformation, two very difficult concepts, very straightforward to articulate in our papers, not very straightforward to implement in practice. So I want to keep in mind something here, which is they're the SDGs, right? The Sustainable Development Goals. The Secretary General's report, 2019, prior to COVID, through 2021, says the pathways to generate transformation required to meet these goals by 2030 are not yet advancing at the speed or scale required. At the same time, only 5% of global climate funding, and this is as of the COP last year, has gone to adaptation. There's also a conditioning factor, and we see it with COVID. We see it in the way international conflicts are affecting global and local spaces. that the global landscape for SDG implementation and commitment to cooperation are under pressure. And I'll come back to what that means for us in responding, adapting, learning, and collaborating in a changing world. So we know adaptation spans multiple scales and activities, from subunits and communities to NGOs in the private sector, and it crosses many needs. This was an image we did with folks in the private sector across national agencies for the UNDRR ARISE, their private sector engagement process. It gives you the sense that we have these timescales of multi-decades, of decades, all the way down to weeks and months. And these are not independent. We know this. For years, we've talked about the distinction between extreme events versus change, and I'll come back to the special report on extremes, on which I was an author as well, but with a very diverse group of people in there. We're asking the question, what does it mean to act as if these scales are connected, which we know they are in practice? It becomes very analytically convenient to separate them in terms of planning and in terms of investments, but we know, in fact, that short-term decisions constrain or enable long-term risks and vulnerabilities, and actually can undermine the long-term adaptation planning processes. So let's think about this. We know there will be more outbreaks as a consequence of extreme weather, biodiversity destruction, political instability. Now that could be describing COVID-19. We just finished a report at the end of last year with the Economic Commission of Latin America and the Caribbean on how COVID-19 was actually undermining the goals of disaster risk reduction and climate adaptation. But this quote is really about the 2018 wildfires in California, which at the time was the largest, costliest wildfire year in US history until 2020. Went from 1.8 million hectares here to about 4 million hectares in 2020. And to draw back the lessons from how we're learning, one of the great things about assessments is what are the threads that come through all of them, so that each assessment is not asking us to turn on a dime, but it is in fact building knowledge on risks and understanding. This figures in the special report on extremes. It makes a distinction for us in framing this conversation from simple risk. How do we manage X or Y? What does it matter? What does that mean for things like reservoir operations, crop yields, so on? How do we begin to think about complicated risks? The idea that risks are connected in time, floods, landslides, heat, drought, to complex and compounding or cascading hazards. In other words, going from one type of event to the next, or having several of them happen at one time. In 2020, which I'll mention in a sec, we were dealing with folks in the Gulf and New Orleans and elsewhere, dealing with the potential for oncoming hurricanes, flooding higher upstream in the Mississippi, together with sheltering for COVID. As we begin to think about those, these are in fact globally connected, and I'll come back to how some of those are in fact linked, and how we think about them in terms of methods and practice. One overarching comment I'd like for us to keep in mind is the traditional risk assessment and management strategies are increasingly challenged by systemic and evolving impacts of extremes, variability, and change. We'll explore this statement in the next few minutes. This quote is actually in the UN Office of Disaster Risk Reduction Special Report, which I co-led last year with people from around the world. This is drawn from experience. That comment has a lot of empirical basis behind it, right? As one of my colleagues, a tribal member in the Four Corners region from the Hopi tribe likes to remind me, he says, uncertainty is not just what you don't know, it's what you have come to know that is no longer true. And so I want to keep that in mind as we go forward in a changing world. So here's a picture. I was on the US delegation for this approval for working group 1, 2, and 3. Here we are from working group 1. It's affecting every inhabited region. It's a really admirable effort in this round of the IPCC to try to get regionally specific and to speak about governance and impacts. But as we think about the assessment of things like heavy precipitation and where they change over time, droughts, floods, how can we involve the dynamics of extremes in the context of longer term projections? That's the however question. So here's an image from the National Research Council years ago that did there, the extremes. extreme heat and extreme cold, we have a pretty good handle on where that's going globally. But as we know, everything from droughts to severe convective storms have a different set of factors together with the long-term drivers of change. The base state is changing because of anthropogenic climate change, but then overlaying on that are the different ways in which we think about changes over time. So how well do we understand the influence of changing climate dynamics on the location, magnitude, frequency of an extreme event? Example, on convection, the conditioning factors for wildfires, flood risks, debris flows. As we think through this, we're actually dealing and taking very seriously the fact that the change is in the present. This is not simply how do we manage for, but how do we manage through a changing environment. So I want to illustrate that by showing this paper from one of my mentors, Randy Dole, on the making of an extreme event. What makes an extreme event? This paper was on the 2010 heat wave and drought in Russia. There's, in black is the climatology. In blue is the climatology and the trend. When we add the boundary conditions of changing oceans, atmosphere, well, actually changing oceans, land, sea ice, and so on, we get the green shift. But then when we add what the atmosphere does in nonlinear ways to respond to this change, we see something that looks like the red conditions. This is, in fact, how extremes are created. That combination of everything from what is the climatology to when we add the trend, the boundary, the initial conditions, and I'm making quite a leap in putting the plus sign there because it's very nonlinear, as we know, leading to changes in circulation. There's the 2019, I like this image just because it shows how, in fact, when you add all of these together, you begin to affect the circulation around the globe, so that even in places where we think wet becomes wetter and dry becomes drier, all of that is actually conditioned as to whether or not the atmosphere responds as we think it's going to respond. The trends are there, as I mentioned, extreme heat, extreme cold. There's no question across parts of the world that we're seeing less extreme cold and more cases of higher nighttime temperatures and so on. But when we add all of these factors, we get a surprise in the system. That's why it's called an extreme. So let's think about what that means. Here's the 2020 Atlantic hurricane season. I'm from the Caribbean. I grew up, always being concerned about things like hurricane. But for many people in the Caribbean, the issue of water is also a critical one. So here is the 2020 Atlantic hurricane season, the busiest hurricane season on record. A lot of impacts. We just finished an effort on climate and migration in Central America. The northern region was affected by hurricanes Eta and Iota very late in their season. But at the same time, in the Western US was the worst fire season on record. So managing these, in fact, parallel risks, in some ways linked to each other because of a changing climate, but also variability and extremes over time, becomes a complex and cascading hazard. But how do we deal with this? In the state I live in, the state of Colorado, 2020 was also the worst fire season on record. So here's some figures from NOAA, who produced this, the excellent economist by the name of Adam Smith that I work with, that takes a look at the physical damage, the material assets, the time elements, the work in disruptions, public infrastructure. There are the United States billion-dollar type losses over time, January through December. You can see there's a seasonality to it. So understanding the seasons becomes extremely important in terms of how we assess risks and how we move ahead. And there's the 2021 billion-dollar weather and climate disasters down in that corner. In the Southeast, you could see a lot of these impacts. And in fact, we're seeing in Texas and Louisiana, actually, about half of all the hazard losses related to floods and tropical storms are actually in those two states. So the geographical concerns and the geographical detail becomes extremely important. What goes into this kind of analysis, and that's a simple version of it, the rate of occurrence, property value, people and agriculture, percentage of property, crop losses. And then below, we see an assessment done by Solomon Shine and others that says, okay, what's the projected economic climate change impact from 2080 to 2019? And when we overlay on that, where the regions are, we see some general agreement but some big differences in terms of how we're experiencing hazards at the moment. And there's the compound hazard county risk for drought, wildfire, and flooding. When we add these all together, we are actually seeing bigger losses than we would see in the projections over time. Now, the projections are very sound. They're very, and so we need to keep those in mind as we think about the overlay of surprises in the system, these combined extremes. The droughts we're seeing in the southwestern US at the moment, northern Mexico, are in fact hotter than they've been over time. When you add heat to dry conditions, you actually can collapse ecosystems. So they're not simply linearly additive. And one vivid representation of that was in 2021. Now here is 2001 to 2020, the temperature maximum anomalies over time, as you could see, very, very heavily skewed in the Western United States. In June 2021, we had an immense heat wave, basically outside the realm of what we're seeing for the projected temperatures. Now, if you look at 4 degrees C, 5.2 warmer will occur 38 times, down to 1 degree C at the present, 4.9 times as likely. This event cost about $9 billion, took in direct mortality about 1,400 deaths, and it was estimated to have killed over 1 billion animals, actually, in the oceans and near shore ocean, of course, to the coast and on land. So beware the bolts out of the blue. These are the things that reset our systems. Anyone who used to teach conservation thought at the University of Colorado, anybody who knows the name Gilbert White knows that the flooding that occurred on the Mississippi, because of his work and others, really changed the way we look at how we manage disasters and risk over time. And he asked the fundamental question, why are losses increasing if we've put so many adaptations and adjustments into place? So one of the drivers that we're interested in thinking through risk are what we call globally networked risks. And these globally networked risks, here's one example of this, and Cynthia knows this better than most people on the planet. The trades of corn, wheat, soybean, palm oil, that's what it looks like. But there are a set of assumptions that we have here, right? Which is they're optimized for trade regimes. They're assuming a stable environment, and they're more fragile than we think they are. We know the 2010 drought and heat wave in Russia affected Middle East wheat imports. Actually, right now, we're seeing evidence that the drought in Taiwan is affecting the production of computer chips for around the globe. So there are many different ways in which we can think about the globally interconnected risk. And in the global assessment report we did in 2019, we basically took a picture of this to show how risks that are globally connected can cascade down to global and to local imbalances. Environmental degradation, growing populations, income inequality, the trade, the complexity of trade, potential for breadbasket failures in different parts of the world, creating food insecurity, and sometimes not creating, but exacerbating civil unrest. I grew up in the Caribbean during the as I mentioned, during the 1990s. Hurricane Andrew and the Loma Prieta earthquake raised premium prices for insurance around the world, including in the Caribbean, which didn't have major storms hitting them at the time. So we share risks and we share responsibility. So change is ahead. As I like to tell people, you don't need to be the Dalai Lama to know that change is ahead. As we begin to see those things, and this is from the National Climate Assessment Report in the US that we did, we're in the middle of creating the new one at the moment. In cities with combined sewer systems, stormwater runoff, there's increased risk of exposure to waterborne diseases, closed roads and networks. The flooding that tends to occur now is larger because of the built infrastructure and because of the nature of extremes. There's an example from a study that was done on Hurricane Harvey over the Houston region. And most of the impacts actually, yes, were the level of the floods, but was also really the release from toxic waste and toxic dumps that stored such material that created a major health hazard. So I want to keep in mind that we have the globally connected risks, and then within environments, cities and communities, there are these cascading consequences of hazards and impacts. And we know what we ought to do about this. There's a whole lot of work telling us about the mix and the value of blue-green infrastructure. And I'm going to come back, and this is in the chapter, as to why sometimes even knowing the economic benefit might not be enough. So for the region from where I'm from the Caribbean, in 2017, a landmark, what we call a focusing year, 22 of 29 Caribbean small island states were affected by one storm, 13 by 2 and 5 by 3. Definitely more than morbidity, right? This is much more than extensive risk. These are major extremes connected, happening from one to the next. 5 by 3 storms. And in one case that is very familiar to people, Hurricanes Maria and Irma impacted Puerto Rico, disrupting medical services, water and cell coverage for up to 125 days in some areas. So basically, this gives a better sense that critical system failures are in fact the thing that led to evacuations and in some cases migration to closures and reduced services. So it's just to give a sense of how these events cascade and compound through our managed systems. The most critical thing was the disruption of medical services. I remember when we did the first assessment years ago in Hurricane Andrew, yeah, the hospitals were well built, the schools were well built, the network getting nurses and doctors to the hospitals were flooded. So as we think through networks, and until the freeze in Texas last year, after Irma, Florida's smart grid needed the longest and most complex restoration in history, even though folks thought they were prepared for it. So this is not simply an island or a continent issue. This is not a developed question. You see impacts cascading through the built infrastructure and systems around the world. So what do we do with this transformation? If it's so easy, we have lots of people, but I always tell people it's easy to ask for transformation when you don't have to do it. If it's so easy, why is it so hard? And there's a lot of good work on this. So the complexity of transitions and of adaptation are easy to underestimate. And there's increasing recognition of nature-based adaptation approaches that arise from ecosystem, and I'll mention that in a second, but there's little commensurate action at scale. And you see that in the context of that 5% number I gave you on adaptation. In the work, a lot of it led by Joanne and Ruth Baer and others in these papers, the question is, can transformation be engaged on a permanent basis? And this is a central theme in the report we're going to release in May at the UN DRR Global Platform. Can transformation be engaged on a permanent basis? What is it? How do we learn to do it? How do we deal with what I've just showed as sometimes unknown or uncharacterized low probability event versus the known or quantified threats? And one of my favorite quotes from Gilbert White was, if we know so much, why aren't we doing better? And to do that, we have to ask the fundamental question about adaptation. Not simply what we ought to do, but when and how often do we need to change our assumptions and put that into our learning? And in many cases, we throw up a lot of barriers for why we do not make the upfront investment. This quote from the Financial Times, which 2016, I have more recent ones that say pretty much the same thing. People are afraid that doing something about climate will make them less off in the near term. But we say, if we only knew the costs and benefits, we would act. Well, the revenue produced by an acre foot, 1,200 meter cube for water for alfalfa in the Western US is $920, lettuce is $6,000, and to manufacture 2 chips is $13 million, but most of the water goes to the first 2. So it's not simply one of knowing the economics. There is the natural hazard mitigation, a really great report. I was one of the external reviewers on this, showing the numbers that we all know. Spending $1 saves you 5, 7, in the case of hurricane surge, in riverine floods, in wildland and urban interface. The investment of $1 upfront, we know, saves you $3 to $7, depending on the type of hazard. And most importantly, more than relocation, more than retrofitting, are the nature-based approaches. Land use planning and design are the biggest return on investment when it comes to managing hazards. We know it's been, that work has been done. The global climate adaptation assessment showed early warning can save lives, investing in better dryland farming works, investments that enable more efficient use of water. There's the returns. $1 trillion in incremental costs of making infrastructure more resilient in developing countries can generate 4.2 trillion. So the economic benefit is actually well known. And in fact, And in some cases, the economic benefit is much bigger than these numbers because it doesn't take into account many times the fact that we have and can protect ecosystem services that gives us multiple benefits over time that actually can create multipliers on these numbers. So what's stopping us? Well, one is that we think it's too complex, but there are adaptations, as my folks in Native communities and always remind me, adaptations do not always require major investments. It can be as simple as reintroducing beavers to build watershed resilience. This is from the National Climate Assessment, showing that very small interventions can help us. We do need larger transformations, but we should not miss the fact that what helps us build trust are some of these smaller interventions over time. So what's another thing that we say? If only we could assess future risks with greater certainty. Do we really need to have it perfectly understood? As the old Chinese proverb said, if we are not careful, we will end up where we're going. This is from the report we did for the UN Convention to Combat Desertification. There's the negative dynamics that increase drought risk, land degradation, high, land cover changes, hydrologic deficits. And there's the positive dynamics that increase drought resilience. We know where those entry points are. We know actually where and how to craft some of these pathways that can either lead us to negative dynamics or positive over time. And we'll come back to what that means in terms of systemic risk. And I've circulated the presentation so you can actually see what some of the details are. And an excellent paper led by Caroline King Okumu that is in the UNCCD bibliography. Here's a figure produced by Peter Glick. Peter Rogers himself started a lot of this thinking. It's in the National Climate Assessment report we did the last time. There's the US GDP. There's the change in 1975, the leveling off of per capita use of water. But you don't see an impact really on GDP. Yet we're told that introducing laws and regulatory demands, behavioral changes, and sometimes efficient technology implies that we will have an upfront loss. Now, there's some similar figures that we have for energy. But as you can tell, there was really no loss of that economic competitiveness by introducing behavioral changes, laws, and regulatory demands since clean water in 1973 and efficient technology. So we're operating under the myth of the upfront cost as having to wait over a long period for the benefits to accrue. So there's an excellent piece of work done by the San Francisco Public Utility. Paula Kehoe led a lot of this. On the right is basically the transportation hub. Work that she put into place way ahead of the California drought. 95% of the demands are non-potable commercial buildings. And now in San Francisco, water systems is a requirement for every new major building. And some of them look like that. Almost a bucolic scene on the top of these roofs, led by this single person. What else do we tell ourselves? Oh, if only we got the communication right. But in all of that, it is more challenging to understand the socialization of lessons learned by particular individuals and organizations. They're the entrepreneurs who change things over time, but they also can create the barriers to communication, depending on their frame. And a key lesson there is what we call the construal level. How do we better connect what we think we know and our own frame with how people act and adjust over time? There's a figure, there's Galileo speaking with the Doge of Venice. We know how some of this ended up. I think this should go over well. The main issue, as we all know, the main assumption about communication is that it has happened. And Lieberman, Trobe, Baruch Fischoff, has elucidated the different ways in which we link, think, and create mental models. But most critically in this frame is that issue of trust. Now, we hear a lot about trust, but there are different forms of trust. And we usually think of trust as being two things. One, rational. Do I have the right information? Is it credible? Procedural. Am I engaged in the process? But there's a larger one that covers both of those, which is affinitive. In our partnerships, do others believe that we have their interest at heart? This is a fundamental piece of trust that makes the rational, the data and information, the procedural, the engagement strategy work. It's whether or not people actually trust that we have their interests at heart. That's where the collaborative frameworks, that thinking actually led to a lot of the design of things like RISAs and so on. And I'll skip through this one. We have a lot of work going on in the security arena. As you know, there are things happening in the world, but the idea is, another thing we say is, we have more critical immediate concerns, and yet we're seeing not necessarily climate events precipitating conflict, but the reduction of adaptive capacity as a result of these events actually exacerbating insecurity. And I worked very early on the much celebrated Syrian case. The person that led most of that was a gentleman by the name of Wadid Arian, who now is in Egypt, basically showing how people were moving from small towns and villages to the largest cities during that crisis. The idea is, how is adaptive capacity lost and resilience lost that then exacerbates the conditions that are in conflict? So, and the last one, this is a nice figure I took from Rob Lempert. It was in the chapter we did for the National Climate Assessment. We have a predict then act frame. This can backfire in deeply uncertain conditions. What will future be? Under what conditions? What is the best near-term decision? How sensitive? But in that framing, uncertainties are estimated, competing analyses can contribute to gridlock, and there's some misplaced concreteness that can increase decision makers' vulnerability to the surprises I just mentioned. It's easy to underestimate the complexities of adaptation. And that person on the left is supposed to be Nostradamus, who says, I did not see that coming. So factoring resiliency is still the safest approach, and therefore we need a shared concept and indicators across both risk and resilience. So how do we move forward? Linking systemic approaches of root causes and so on, and globally networked risk, with windows of opportunity. We need to acknowledge that cross-scale nature of early warning across climate timescales. The IPCC reports and others are early warning about changes into the future. The linked timescales are the ones on which we're acting. And we ask the question, where might investments be prioritized to reduce future risk across this continuum? Right now, we have a mismatch on that sub-seasonal, 2-week and longer to seasonal on responding to emergency events and then planning for long-term change. And there's that gap, a sovereign liquidity risk that exists in that gap on the sub-seasonal timescale. So what are the best metrics approaches? So this is in a paper we did in the Society for Risk Analysis a while back with Igor Lenkov and others, the physical information to prepare, absorb, recover, and adapt across homes, neighborhoods, towns, regions, and states, asking what's the data on each of these that we have on preparedness, absorption, recovery, and adaptation, on the physical, the informational, the cognitive, and the social. And most critically, the vertical and the horizontal. The large awareness here is that managing for resilience is different than managing for efficiency. Many times we reduce efficiency to using the last drop, when in fact, everyone who has insurance knows that resilience requires a buffer. The role of nature-based solutions, the role of ecosystem-based adaptation, and the ways and link in which global to local and horizontal shared visions and watersheds and so are networked. Designed to maximize efficiency, designed to maximize resilience, but requiring multiple levels of interaction. And there's a framework for thinking through this. The other thing we do is to broaden the actor network and their roles. And it's not, we don't need to rediscover the local at every meeting or at every talk, nor do we need to always think, that the global mechanisms meet local needs. Both centralized and decentralized approaches are needed. National and subnational governments, this figure is actually in the global assessment report we did. And most critically is to ensure accountability through political authority and coherence down to the local and back up, actually. One of the biggest issues we have with decentralized approaches is that we decentralize them without moving resources to the local level. And most critically, partners do not just share data. So that's a weak notion of co-production. They share risk and responsibilities. They co-develop the future together. And in that setting, we are aware, we assess, we plan, we implement, and we learn. This figure is in the National Climate Assessment Report. So to wrap up, we have measures of resilience. The operational aspects, that is the top of the iceberg on how we use resources, the data, the numbers, and so on, the feedback loops at that level. Once we begin to get into what used to be called the practical range of choice, the culture, the capacity to communication, who is at risk, who acts on their behalf, we begin to get closer to the rules of the system, the power to self-organize, and the mindset out of which our goals and our feedbacks and opportunities for collaboration comes in. So governance is critical, as we know, but now we've talked a little bit about what that looks like. We've talked a little bit about what trust and partnerships are. We've actually talked about what constitutes asking the right question, not just responding with data and information. As I many years ago, we should not be in the business of helping people do the wrong thing with better data. At the top level, we run the risk of what we call system decompensation, using up buffers, externalities as we call it, and thinking that we're being efficient. When in fact, we really should be in that realm of resilience, synchronizing across units, roles, and levels, and what we call in the disasters community, prospective learning. To be proactive, yes, let's plan for what if in a predict and act sense. But to be prospective means to reduce the likelihood of new and emergent risks coming about. And that's where adaptive management comes in. So what is the challenge? To sustain collaborative networks and the individuals across research, observation, services, and decision-making. And I can draw many examples for how we've tried to do that in different parts of the world that is beyond the project level, but is actually embedding people in practice. From global to the local, for exposure to vulnerability, I wanted to thank Martin for helping us navigate through a very complex world and to remind us that that young person on the top left is waiting. Thank you.
Thank you, Roger. That was such a treat to hear your insights first, and thank you for sharing your insights across decades of work on climate extremes and the societal response to them, and your dedication. I have to just honor you for your dedication for working to help society all over the world, not here, both in the United States and all over the world, to actually confront the incredible challenges of climate extremes in all their in all the panoply of their of all the factors that and processes that you brought forward. So many thanks. I want to just welcome David Rind, who is the co-editor of the whole series of books on our warming planet, and welcome our next speaker. Well, Linda, we're coming to you in a few minutes for your Linda Mearns is the second speaker this in the webinar today. But we do have a little bit of time with Roger for Q&A. Manishka is going to lead it, and she's going to start off with some questions that are just to you about about the decades over which you've been doing this great work. So, Manishka, over to you.
Thank you, Cynthia, and thank you, Roger. That was really fantastic. And I encourage everyone in the audience to please start typing your questions in the Q&A box, and we'll get to as many of them as we can. So please start typing your questions. And in the meantime, Roger, I do have a couple of questions for you.
Sure.
Could you please share your career journey and how you started working on climate change?
Absolutely. No, thank you. I'm always hesitant, when we say things. I mean, I've looked up to people like Cynthia and so on for years. When we say, oh, we've been doing this for a long time, because then that begs the question, why isn't it better? So I wanted to basically describe it as a learning process, not as something. Right? So I actually grew up in the Caribbean, as I mentioned, grew up in Trinidad, in a small village, an agricultural village. And the first thing that occurred to me, it's one of the most ecologically diverse places in the world, was the link between folks in agriculture, their seasonality of their jobs, and the impact that climate and weather events had on their livelihoods and their perceptions. But more than even than that, as folks like Aaron Wolf and others, we talk about, is the way that seasonality and the events were then tied to their culture, ceremonies, and perception. And so that connection between the meeting basic needs of food, water, and energy, together with how culture shapes how we think, becomes very, very important in the context of thinking. So from there, having worked in agriculture as well, the idea was to get engaged in even since from that time, actually, in college, in thinking about how we can better use science to help people adapt, adjust, learn. And then later on, most critically, half of my training is in public policy as well, even though I worked on deep convection in the Amazon basin for, was really this awareness from people like Gilbert White and others that the sense of human dignity of people being able to make their choices was what we were after. Not necessarily simple outcomes that are metrics of productivity or yield, which is extremely important, but how people make choices about their own lives. And then, okay, how do we bring science, information, data, and knowledge to bear on helping that happen? So that's the background.
That's great, Roger. Thank you so much. So we do have a question from Jeff Dalhoff. What framework or model do you use for measuring the costs of extreme climate change events?
Yeah, so I can, the immediate costs, right, which are really, I think I put up on one of the figures, the types of things that go into that. I have on there, things like losses of work time, losses of building impacts, things like that. And they're mostly insured losses, quite honestly, because that's the best traceable accounts. Now, within that are not things, as I mentioned, like natural capital and so on. So I don't pretend that these estimates, which Adam Smith, as I mentioned, is the lead on all of that, are in fact anything other than benchmarks for how we might think about losses. So I don't want to put too much. I mean, we have in the Global Assessment Report a section on the difficulties of actually getting precise economic numbers on these things, but it's a set, it's basically a set of input-output type models. And I do want to keep in mind, though, that in those, and I have them listed on, I think, one of the figures there, on the types of things that go into the assessment, ag productivity, building damage, as I mentioned, that they're really underestimates of the risk as they filter through. We really do not understand the multipliers through environments and economies very well from one, things that are secondary and tertiary. So I'm not claiming that I know what those are. I'm just saying that these are benchmarks, and they're pretty much, I think, a low-level benchmark, because the multipliers and $1 loss to someone who needs $1 is different from someone who has $10, and drawing those distinctions are very critical. So I actually don't want to reify the methodology in that sense. Yeah.
Thank you, Roger.
But I do have the model up there in one of the figures. So.
Great, thank you, Roger. We have one more question. Sarosh Poya says, thank you very much for the wonderful presentation. I wonder if you have looked into the concept of climate change and proxy wars.
I'm not sure if I use the same framing, but can you say more what you mean by proxy wars? Because, and I'll tell you why I'm saying this, I have a sense of what those words mean, but I make a distinction between proximate drivers of conflicts and, in fact, more embedded things that are socially constructed. So that we have quite a lot of work going on that has been done, written up in places like India and Pakistan, the Caribbean region. We just finished a whole bit on conflict in Central America, but I'm actually basically saying that it's about how we think about adaptive capacity in responding to in places of conflict than as drivers of conflict. Another big place in which we have that kind of work going on is in East Africa. So if we want to talk in the Horn, so if we want to talk about that sometime, we can. Yeah.
Great, thanks. And we have a question from Thomas Brewer. Thanks for the excellent presentation, especially inclusion of cultural factors. I have spent a lot of time in recent years in Denmark, Finland, Sweden, and Norway. I'm always amazed by the differences in attitude towards climate change and their determination to do something about it. Could you offer any data, cases, intuitions, and compare them with the US?
So, as you know, a lot of data, I mean, certainly out of Tony Lazaret's group and others have shown that, that yes, there's that willingness, right? But the reason why I took the tact in the paper, in the book, and in the presentation, that we express that willingness, certainly in the States, but then we find reasons for dodging the responsibility. Not everyone, I'm not making that claim at all, otherwise we would have nothing in place. I mean, the best example of that are things like our national parks. Now, in that setting, I do think there's a lot of positive efforts going on at local communities, and I work with several of them that are in parallel with some of the Scandinavian examples. I will, however, take issue with one thing in both cases. Both places, and this applies around the world, and this is why the globally networked risks matter, are not as well engaged in how we actually address the impacts of our choices on the rest of the global economy and on people. And I'm pointing fingers at both of us in doing that. I think there's a lot of attention, certainly in the countries you mentioned, on trying to pay attention to the risks that and the causes about climate that affect what they're doing. I see that in different communities, not necessarily, across scale, across the entire society. We can't, a culture of acting that way in the way I think you're describing. But I would not also background a sense of almost irresponsibility with the decisions we make in both places about what happens in the rest of the world.
Thank you, Roger. I think we have time for one more question. It's a very interesting question, and then we can wrap up. So Haida Ali says, is there any focus on studying the oral history passed through generations among Native American nations?
Absolutely.
Find if there is some information on how they survived sea level rise due to climate change thousands of years ago.
Yep. So I'm really glad you asked that. One of the things I took out in the interest of time that is in the paper is very much geared towards people that we work with in what we call the Four Corners region of the U.S., right? Colorado, New Mexico, Arizona, and Utah. And I'll give you a quick joke there. A colleague of mine who's there, the Hopi, we work very closely on what does the changes mean over time, and then how are people adjusting and adapting within their own cultural context. There's a lot in there. And one of the things we do, I sit on their traditional ecological knowledge group, is trying to make sure that we're being objective. And by objective, I mean the old definition, the Greek definition of objective, bringing all relevant information to bear on a problem, not trying to reconcile an oral history with a climatic observational history, but ask, what does this tell us and teach us about how we ought to act? One of the things I'm most proud of, and Cynthia was engaged in this, is when we did AR5, that was the first time that a summary for policymakers said that Indigenous people are not just vulnerable, they have stories and insights to share that helps the world adapt. And we basically crafted the Weathering Uncertainty report, which actually showed that around the world. Now people know that. And what I was going to tell you is when we were conducting the adaptive management program on the Grand Canyon, a Hopi elder turned to the Secretary of Interior and said, adaptive management, we've been here for 10,000 years, you guys just showed up. So I want to make sure that we're actually trying to bring to bear the experiential in addition to other approaches. So I really appreciate the question because I didn't have time to go into it, but it is a central aspect of what we do. Now, that being said, I'm a member of the American Indian Science, fellow of the American Indian Sciences and Engineering Society. I do want to be clear that neither are we romanticizing the knowledge. We're asking, well, how do these partnerships among people help us think through society, environment, economy, and more critically, equity? So it's an extremely important question, and yes, it is something we pay attention to, but we try to be very careful with our partnerships and respectful. So.
I think we'll end there. I think, yes, on a very important question. And thank you again for your answer. And thank you for the contribution to the book and for your fantastic lecture today.